Why does the choice of statistical test matter? Well, the answer is simple. The right statistical test can provide accurate and meaningful results, while the wrong choice can lead to misleading or incorrect conclusions. To choose the right statistical test, several factors come into play. These include the study design, the type of data, and the specific research question you're trying to answer. So, let's break this down into manageable steps. First, consider the nature of your data. If your data is numeric and normally distributed, it falls under the category of parametric data. For one sample, use the one-sample t-test to compare the mean of a sample to a known value. For two independent samples, the independent samples t-test helps compare the means of two distinct groups. If your samples are related, the paired samples t-test is your go-to. And if you're dealing with more than two independent samples, analysis of variance or ANOVA is the test to use. However, if you're dealing with non-parametric data or ordinal data, the tests change slightly. For one sample, the Wilcoxon signed rank test is used to compare the median of a sample to a known value. For two independent samples, turn to the Mann-Whitney U-test. If your samples are related, use the Wilcoxon signed rank test for paired samples. And for more than two independent samples, the Kruskal-Wallis test is your best bet. Next, let's talk about categorical data. If you're dealing with two categorical variables, the chi-square test is used to assess independence. If you're looking at the association between two variables, one categorical and one numeric, you can use the point biserial correlation, or Spearman's rank correlation. If you're looking at the association between two categorical variables, Kramer's 5 or the phi coefficient can measure the strength of association. Now consider the experimental design. For a before and after study, use the paired samples t-test or Wilcoxon signed rank test. For a matched pairs design, McNemar's test or the paired samples t-test is ideal. And for a repeated measures design, use the repeated measures ANOVA or the Friedman test. Regression analysis is another vital aspect to consider. If there's a linear relationship between variables, use the Pearson correlation coefficient. To predict an outcome, opt for simple linear regression or multiple linear regression. Comparing variability or dispersion. Levine's test can determine if variances are equal across groups. Finally, if assumptions for parametric tests are violated, consider non-parametric alternatives. For instance, use the Mann-Whitney U-test instead of the independent samples t-test, or the Kruskal-Wallis test instead of ANOVA. In summary, choosing the right statistical test is crucial to obtaining accurate and meaningful results. The choice depends on the nature of your data, the type of variables, the experimental design, and the specific research question you're trying to answer. So remember to consider these factors and choose wisely.